right, 10.3. We're looking at data. So we're going to make some dot plots to show the information here as a dot plot like this. One of the things that we need to understand is when we're looking at data, there are different kinds of distributions. So when we look at this distribution, we notice that it kind of is weighted toward the right side of the graph here. So like you see this line, it's kind of weighted to the right, but you see this one is very even in the middle. So it's equal on the left and equal on the right. So there's ways that mathematicians talk about that, and if we turn back here to page 452, we see these terms. One's called skewed left. What that means is that data kind of is mounded up over here on the right, and it's skewed to the left, which means that it has like this tail to the left, and then there's drop off at the right. So the drop off is not the skewing, it's how it tails off or trails off here. So here we have like it falls off to the left and it trails off toward the right. That means it's skewed right. When it's kind of equal on both sides, makes an equal mountain here, it's called symmetric, or it's symmetrical. Symmetrical means the same on both sides. If I was to put a mirror here in the center, it would look the same on the left and the right. That's symmetric. Skewed left means it has like a tail and it's mounded up on the right. Skewed right means it has a tail to the right and is kind of mounded up on the left. That's what these terms mean, these distribution terms. So when we get to the assignment that we're going to be working on today, and it asks us, describe the shape, it's looking for that. It's looking for skewed left, symmetric, or skewed right. That's the information that it's looking for. On the first two, and I'm going to do number 3 with you right now, it wants us to build this number plot. So make a dot plot. So we're going to do number 3 here. And the first thing we always need to do when we're making plots or graphs or anything is we need to look at the smallest and the largest. So the smallest is 0. It looks like the largest is 6. So let's look through this really quick. Yeah, the largest is 6. So we need to make a line plot. So I'm going to bust out my ruler here, and I'm going to make a line plot. And I'm going to use centimeters here because centimeters are easier for me to use. So I'm going to start here is where the line will start, and then this will be 0, 1. So I'm going to put my numbers on each centimeter. 1, 2, 3, 4, 5, 6, and I'll go one more because that's where my arrow will be, because it's a number line, and remember number lines have an arrow on both ends just to show that it's a number line. So here's 0, here's 1, here's 2, here's 3, here's 4, here's 5, and here's 6. I probably should have left more space above it, like these ones do, but is it absolutely necessary? No, it's not. So now what I'm going to do is for every piece of data that's on here, for every number, I'm going to put a dot on the number line here. That's how you make a dot plot. So here we go. I got 1, and I got 2, and I got 4. I got another 1 here. I got another 2. I got a 6. I got a 0. I got a 3. I got another 3 and another 2. I got another 2 and another 4. I got a 1 and a 0. I got a 2 and a 5. I got a 4 and a 3. And you can kind of see I'm trying to have them like evenly spaced. That kind of helps to look at the data when you're finished. If they're all crammed together on 2 but not on the other ones, you know, let's say, it kind of makes it hard to interpret the data. So if I try to make equally spaced dots, it really helps to be able to see. All right, so let's look here. It looks like it's kind of piled up more to the left. If my graph was compressed more, it would look like it had a long tail over here and it fell off over here. So I'm going to say that this one looks like it's skewed right. So it looks like it's skewed right. Okay, and it says in your own words, and that's what I try to say. It looks like it's piled up over here on the left and kind of has a long tail to the right. So that's what they mean by describing your own. But if you can use the words that they gave us, skewed left, symmetric, skewed right, yeah, that helps too. That makes it a little bit. It gets you into the kind of gets you into the practice of saying the math vocabulary correctly. So you'll do number 4 here. I won't do number 4 with you, but I will do number 5 with you. So I'm gonna put number 5 right here, and it says describe the shape of each distribution. So when I look at this, it looks like the tail's over here to the left, so that would mean skewed left. So skewed left. You'll do the same thing for 6. For 7, it's not a dot plot, but you can kind of see how it does the same kind of thing, and same thing with 8. So you're going to do that for those two.